Hi, I'm Mike Peel, and I'm from DevCon. We're here today for a very special AMA with Hans Dockter of Gradle. He is the CEO of Gradle Inc. and also the founder of the Gradle build system. So first thing first, I just wanted to ask you, what was the genesis of this great tool for developers called Gradle?
Hi, Mike. Thanks for inviting me to this interview. Looking forward to DevCon end of or beginning of December. So regarding your question, why did I create Gradle? In my role as a software engineer, I always took on the responsibility of automating what was possible to automate. Basically, for me, it was always a foundation for high-velocity teams that you have a maximum of automation, a maximum of automated feedback. And as part of that role that I took on in often pretty complex projects, I grew more and more frustrated with the tooling, deeply frustrated, right? So I reached a point where I said, hey, it's a disgrace for the industry, right, for our craft, that we don't have tools that help developers to be more productive, and that basically triggered first me toying around with some ideas I had, and then seeing that those ideas are valid, then to fully pursue that and establish Gradle as a now very widely adopted open source project.
How many years did that take from toying around to basically version 1.0?
So it's interesting. I mean, so from toying around until version 0.1, it took maybe half a year. And the interesting thing is, things were busy from day one. The mailing list was busy. You could go back to that day, and I mean, not as busy as today, but still, there was interest from day one, and that gave me the energy to move forward. We were very conservative with the 1.0 release. With hindsight, probably too conservative. So we had already significant adoption before that, right? We had the first enterprises using Gradle. They started with using 0.5. The Hibernate project, the database, or mmapper, migrated to Gradle when it was definitely before 1.0. LinkedIn split with Gradle when it was 0.9. So we took a long time until we released 1.0, and there was several years, right, until we released 1.0. But frequent releases always in between, right? And that for us, 1.0 was an important landmark, because we said from now on we guarantee backwards compatibility, which is a burden, right? So that's why we were reluctant to release a 1.0.
So I'm going to hop into the simple questions. So what are some of the features that Gradle gives teams doing multi-project builds? How does Gradle help a team manage a multi-project build?
So big part of Gradle is dependency management, right? And for us, dependencies, you have external dependencies that you need to build from scratch, and we have a very flexible model for that. That depending on your context, right, you can decide which dependencies you want to build from source, from the sources that you have checked out, from the sources that might be in your dirty working copy, right, not committed, and which of the dependencies you want to have as binary, as published dependencies, either by your team or being external open source dependencies. So we offer you a lot of fluency that is different than what other build systems are doing, and now with the latest Gradle, we have the concept of modularization goes even deeper. You can now basically declare, when you have multi-module builds, right, you can declare the API for a module. So you can say, I have a certain set of source code in this module, but only only those packages, right, are the API of the module and can be consumed by any module that depends on that module to enforce better API design across the teams, and to help keep all the different modules to be in a more evolvable state, right? And not every module is basically using every single class in the other module, which makes it very hard to evolve any API forward.
So Gradle is both declarative and imperative. So how does it bridge that gap, and is it losing any of the advantages or disadvantages of both styles?
Yeah, that's a very good question. So the way we see it is there are different layers of responsibility. If you look at an organization with a smaller team, they're merging, but even if it's one person, this person might have multiple hats, right? So our approach is that the developer, that the final consumer and user of the build system should work on the declarative layer, right? The developer should be enabled to describe her requirements in her language, in the language of the software development domain, not in the language of the build domain, right? Hey, in Android it would be, hey, I have I have a source directory here, I have instrumented tests, I have certain variants, right? I have certain build types, and so basically it's the what of your project, right? In the terms of an Android project, how a developer would describe an Android project, and then we translate the Gradle Android plugin, and the Gradle core platform translates that into low-level build system concepts. If you're now a build master that wants to do some nifty additional customization of the build, you have some, you have some legacy requirement, you have some complex, let's say, resource generation that you want to use in your Android app, then you have to understand the imperative layer. And then the imperative layer that underlies the declarative layer gives you all the flexibility to hook in where you need to hook in, and so that you basically, that Gradle is not in your way to implement all the customizations you need to implement, and gives you all the flexibility that you need, right? So it depends on basically the role of the person, where one layer is more important than the other layer. In fact, if you have complex customizations you want to do for your organization, it is even the job of the build master to add to the declarative language of Gradle. You can extend the language, right? You could create a very declarative language around Android integration testing, right? And devices you want to use for that. And the developer could use that language, and again, your customization would then translate that language into the build concepts to execute basically what has been declared.
You're basically trying to avoid imposing any strict laws on the developer in the organization, depending on what their role is. You want them to be able to do their role the best that they can within the scheme of that.
Yeah, but the highest value basically for us is create a build system that is very easy to use by developers, and yet gives them the power they need. That is the golden line that we are trying to find, right? There are build systems out there that are very easy to use, but once you need certain things the build system hasn't anticipated, you run against the wall. And then there are build systems that are very powerful, but they expose all the complexity of the world to every developer to get anything done with this build system, which is usually what developers are not interested in. They don't want to become build system experts, right? And that is that fine but very important line. Gradle enables you to basically to create for your developers that they have enough flexibility, but still a lot of structure, that the build system is approachable and easy to use. So
how does Gradle help developers manage the complex and often hairy world of dependencies or dependency management through integration testing?
So dependency management is a key strength of Gradle, right? Be it your source dependencies, as I've talked about it before, or be it external dependencies, right? And with all the challenges you might have in that domain, version conflicts, name changes of dependencies, Google Collections turns into Google Guava, and basically we give developers all the tool to create to model the potential challenges you can have there, and that Gradle can make the right choice, that you get a solid and stable class path basically for your application, right? In terms of integration testing, it's also a topic very dear to us, and you can model with Gradle very complex integration testing scenarios. It is not specifically related to dependency management, right? Except that your integration tests might have specific dependencies that you can easily model with Gradle, but those are almost two separate domains, the way I see it.
Okay. Let's see if we have any questions from the audience before I hop on to the next thing. Don't have anything popping up. So where do you see Gradle moving forward in the next couple years? As far as where what do you anticipate that you'll have to?
Oops, Mike, you're breaking up. I can't hear you right now. Okay, I just got some feedback from our folks that people can still hear me, but that the interviewer, that Mike, has basically vanished from the Hangout. So I will at least answer the last question. Where do I see Gradle going? So there are a couple of areas that are that we work on very intensely. So first of all, what is super exciting is that we could increase our R&D bandwidth significantly this year. So so we can basically tackle now more features at the same time. And one key area for us is performance, right? That we made some amazing progress already over the last Gradle releases. And that is something where we will add a lot of capabilities over the next basically every month until way into next year, right? It's a distributed cache that caches all the build outputs, even smarter incremental build than what we have today. We improved the up-to-date checking times tremendously, but there's still more that we can do.
Hi, I came back.
Okay, hey, just started to answer the question.
Okay.
Where's Gradle going? And then finally, going fully distributed, right? Finally adding the capability to be able to take a single build and distribute it across as many machines as you want, right? And so that is one very important area. The other very important area for us is to model more abstractions in our domain. So, for example, make services, microservices, a first-class citizen in the Gradle world, right? You can use Gradle very efficiently right now already to model a continuous delivery infrastructure for microservices, but we want to make the concept of a service, right, a first-class citizen, which it is not right now, including dependencies between services, right? That we can basically understand the whole chain of services, what is downstream, what is upstream, that we can spin up the services chains that is required for you to do certain experiments, for example, on your local machine, or for running integration tests to figure out whether you've broken any services downstream. So that is the other big topic that we want to deliver to some degree already next year. And our current focus, the main focus is, and that's particularly important also for the Android listeners, we are working on the next generation software model for Gradle. It's not in production yet, but it's making good progress. And the experimental Android plugin, right, that is already available, right? It's the next version of the Android plugin that will eventually replace the current one, is already using this next generation software model, which increases again the extensibility of Gradle and the Gradle Android plugin, which makes configuration time faster, and that brings a lot of advantages to the Android community. So those are the things that you can expect over the next months and in 2016.
Well, just to continue the idea of evolution, it seems like Android itself is a completely different world than it used to be a couple years ago. When you think about mobile development and what a big game changer that was, the next thing is IoT, wearables, a world of sensors. How do you think that's going to change application development going forward? And
I would say that there are a couple of, I mean, what if you translate that into particular challenges, right? What challenges do we have here, right? So one challenge is what some people call fragmentation. I call it diversity, right? Mm-hmm. So you have a similar software that have certain variations for different target platforms, right? So and that will be an ever increasing problem, right? So and the key reason why